Hello, good morning, student. I hope you all are happy and healthy and very fine at home. So, what did what did we learn yesterday, or what did we discuss yesterday? Yesterday we discussed about 1-3 type, and 1-3 type. In that we have learned trans 1-3 AE or EA form, and there we have considered the example of CH-1 dimethyl cyclohexane. CH-1 dimethyl cyclohexane, with respect to the following point, we have learned this step by step. So first one, optical isomerism, second one is a conformational isomers, and third one is a relative stability. On the basis of we have learned these things. First one is a optical isomer. By looking as a model, there is no plane of symmetry, and therefore that stereoisomer is optically active in nature. That conclusion we have drawn. And conformational isomerism, there are some of the enantiomers are present that are the conformational isomerism, and some of the relative stability we have calculated. Only one methyl group which is present at axial position, and there we found 2-1-3 diaxial interaction. At 1-3 position, whatever hydrogen atoms are there, they are gauge, and therefore that type of the interaction is called as a 1-3 diaxial interaction. There is no butane-gauge interaction, and therefore by using that method, according to that method, we have calculated the energy of that. So today we are going to talk about the order of stability. The order of stability of conformers. Stability of conformers is, right? Now, so far we have in a 3 type, we have got different 8 structures. Out of that 8, there are only 3 different structures, and others are similar with that 3 structure, and therefore we are going to compare the energy within that 3 isomer. Let me draw that 3 isomers which are here. One structure I have drawn here, another structure I am drawing here, and the third one maybe as this one, right? Now we are talking about stability order, that is a type number 3, that is a 1-3 type, right? 1-3 type or type number 3. 1-3 means substituent present at 1-3 position. When look at here, the numbering are same in every case: 1, 2, 3, 4, 5 and 6. Here also you consider 1, 2, 3, 4, 5 and 6. In this structure also 1, 2, 3, 4, 5 and 6, right? Now look at here, the 1-3 position, the methyl group which is equatorial, that methyl group which is present at equatorial position. So that one is, and we know that the equatorial disubstituted cyclohexane are more stable than the diaxial substituent cyclohexane. Now let us look at another methyl group which is at this position. Look at I have drawn, or I have attached the methyl group at an equatorial position, and therefore what do I get? Here methyl group which is below the plane, this methyl group is below the plane, and therefore from that I know that this is a cis form, right? Cis 1,3, that is a E form, right? E form. And now similarly this one I am going to draw here one of the methyl group which is present at axial position like this. This is axial position, and now another methyl group I am going to put at these 3 position at equatorial position. Can you tell me what is the form, whether it is a cis or trans form? Yes, one is above the plane, one is below the plane, and therefore it is a trans, right? This is a trans. And now trans 1,3, what type of the form it is? One which is present at axial position and one which is present at a equatorial position. Therefore trans 1,3 AE form, right? Trans AE form or EE form, one and the same thing. Now look at the third structure. Observe the third structure carefully. Again I am going to put both the substituent. One substituent I am going to put here at this position, axial position, and one which is present at another one which is also at a axial position. What type of the form it is? Both the methyl group which are coming on the same side of the general form, and therefore this is a cis conformer, right? This is a cis, and the substituent, the relative position of that substituent are 1 and 3, therefore it is 1 and 3, right? Now what type of the form it is? It is a form, isn't it? Now look at here carefully, observe these 3 structure carefully. Now we are talking about the order of stability of conformer. While arranging or while discussing the stability, for that purpose we are actually calculating the energy, internal energy, or what we can call it as a van der Waals strain. And if we know the energy, we can comment on the stability of these conformers. So first of all, calculate the energy consist of these conformers, of these different conformers. Here observe this first structure carefully. Both the substituent, they are present at equatorial position, therefore in the first structure there is no 1,3 diaxial interaction. No 1,3 diaxial interaction, as well as there is no butane-Gauch interaction, and both are absent. What will be the energy of this conformation? The energy of this conformation is a 0 kilocalorie per mole, right? This is a 0 kilocalorie per mole of van der Waals force, right? Per mole of van der Waals strain. This much amount of the energy consists of this first conformer. Now look at the second structure. Observe the second structure carefully. What do you see here? Here you can see clearly one of the substituent methyl group which is present at axial position. Yesterday we saw that a model, and from that model we easily understood that axial and the equatorial. Now also by careful observation of this structure, this is a methyl group which is present at axial, and therefore first thing, find out the 1,3 diaxial interaction. One methyl group at axial position, so there is a 1,3 diaxial CH3H interactions are there. So how many are there, that you have to calculate. How to calculate that, how to recognize this? First you count on both, first clockwise, another one is a counterclockwise. If you clockwise, look at here, 1 2 3, one hydrogen which is below the plane equatorial, one must be above the plane which is present at the axial position, and that axial position they are nearer this methyl group. That type of the interaction is called as 1,3 diaxial interaction. Okay, now go this side, counterclockwise manner. 1 2 3, look at carbon number 5. There are two hydrogen, one hydrogen lying at equatorial position and one which is present at axial position. For sake of convenience to understand, I am showing only the hydrogen, those are creating, those are producing the 1,3 diaxial interaction, that I am showing only here. Look at here, so that you can clearly understand this 1,3 diaxial interaction. Now 1,3 diaxial interaction, how many 1,3 diaxial interactions are there? Here is a 1, there is a 2. So total number of diaxial interaction is a 2 into 1,3 diaxial interaction has 0.9 kilocalorie. This much amount of energy consists there. So here multiple by 0.9 is equal to, you will get 1.8 kilocalorie per mole. This much amount of the energy here consists this conformation, right? Trans 1,3 AE or EA form has 1.8 kilocalorie per mole. This is a greater than, this is a 0 and this is 1.8. If you compare the stability between these two conformer, one is a EE form, AE form, and one is a EE form, which conformer whether cis-1,3 dimethyl cyclohexane is a more stable or trans 1,3 dimethyl cyclohexane is a more stable. Absolutely correct. Here this one, those are having as a less internal energy, they are greater in stability, and therefore cis-1,3 dimethyl cyclohexane is a more stable than the trans 1,3 diaxial interaction, because it has a higher energy, less will be the stability. That general guideline you must remember while talking about the stability of this cyclohexane. Now look at here, cis are there, and therefore 1 2 3, at 3 position there is a methyl group, and this is also as a methyl group. They are coming at the 1,3 position. Yesterday I already told you that if methyl interactions are there, 1,3 diaxial CH3 interactions are there, they produce 4 times greater than the 1,3 diaxial interaction. So you know that the 1,3 diaxial interaction has 0.9. So here methyl group is there. So 4 times means what? 4 multiple by 0.9, you will get as a 3.6, right? This one methyl group. Now look at here, 1 2 3. At this position here is one hydrogen atom which is goes to this methyl group, and therefore there is a 1,3 diaxial interaction is a 1 here. Now this methyl group, look at here, 1 2 3, which is also goes to this methyl group. How many number of 1,3 diaxial interaction you find here? There are 2 1,3 diaxial interactions are there, and therefore 2 multiple by 0.9 equals 1.8. If you add this one, total how much energy you will get? You will get 4.5 kilocalorie per mole, this much amount of the energy associated, means if you order of stability of this conformation, which is the most stable one and which is the least stable one, this one is the least stable one, this one is the most stable one, and therefore stability order, this is the most one. This or you can draw the what we can call it, you can show this type of the symbol, mathematical symbol, which clearly indicate that as we go from this side to this side, the stability goes on decreasing. If you goes from that side to this side, this is the most stable one, this you can call it as the most stable conformer, and this is a least stable conformation, right? Least stable conformers. So in this way we have completed the stability, the order of stability of conformers of 1-3 type. I think with this let us stop today here. Remaining we will see the next time. Have a nice day. Thank you.